Hello, and thank you once again for your interest in ArchiFrame. In this presentation, I will explain how ArchiFrame helps make design, production, and building processes more efficient. So what kinds of problems or challenges does ArchiFrame aim to solve? Basically, it helps to reduce errors and inefficiency in a few key transition phases of a building project. These are the transitions from, first of all, the architect's model to the structural model. Secondly, the transition from the structural model to the element factory. ArchiFrame makes it very easy to produce accurate documentation for factory production. The third transition that ArchiFrame helps with is the one from the drawings and factory elements to the building site. Most importantly, with ArchiFrame, it is less likely that workers on site are given contradictory drawings and building elements. So, have you experienced any problems with any of these transitions? I'd be very curious to hear. Okay, well, I can try to emphasize that in the rest of this presentation. Now I'll just briefly introduce what ArchiFrame actually does and what it is. So ArchiFrame is an Archicad add-on for modeling wooden structures, although it also works for other materials like steel. The idea is that you start with an Archicad model, which is made by the architect. Then, based on this Archicad model, you create the ArchiFrame structural model. So then the architect's model and the engineer's ArchiFrame model are both in the same file. Then from this one file, you can generate different kinds of output, including element elevations and quantity takeoffs. Note that you can also edit the 3D model through these element elevations, so it's not just a one-way street. Secondly, you can create architectural drawings like sections and elevations. You can also create a BIMx model, which can be shared with clients or construction workers. And you can create an energy evaluation report, among other things. And there are several benefits to having one file that contains both the architectural and structural models and generates all the output that I mentioned. So first of all, you have to spend less time on transferring files from, for example, Archicad to DWG or some other format. You also need to secondly, having the architectural and structural models in the same file also helps you avoid mistakes that happen during file transfers and updates. If you work with one file, then it is easier to ensure that this one file is always up to date. And thirdly, creating both the architectural and structural models with the Archicad ArchiFrame package means that you only need to learn one software, and this again saves you time. So now that I've explained the big picture of what ArchiFrame aims to do, we can delve into some more details. In this presentation, I'll first start by telling you about ArchiFrame's specific features and tools. Then I'll go through some use cases and references. Thirdly, we'll have a look at different license and pricing options. And finally, I have some videos demonstrating how ArchiFrame works in practice in even more detail. So let's start with ArchiFrame's features. I'll go through our most important features from the design and planning phases through to the production and ultimately construction phase. I will talk about how ArchiFrame makes each of these phases more efficient and less error-prone. So starting with the design phase. First of all, ArchiFrame makes the iterative design process much smoother. One reason for this is that, as I mentioned, the ArchiFrame structural model is in the same file as the Archicad model. This makes it easier to notice updates to the design, and it also means that you don't need to convert files from one type to another. And in addition, Archicad's teamwork feature also facilitates cooperation. With teamwork, the architect and the engineer can work on the same project simultaneously. This means that you don't need to transfer the updated file from one team member to another. Instead, the single teamwork file is always up to date. And here's a video showing how quickly you can update your structural model using Teamwork and ArchiFrame's tools. So here we're going to update the ArchiFrame structural model after an architect has made some changes to this model. So you can see how the Archicad and ArchiFrame models are in the same file. For example, the walls with brown stripes are Archicad objects. And on top of them, you can see ArchiFrame structures. So for example, the blue rectangles are wall studs, and the other layers in the wall are represented by black lines. Here's the teamwork dialog, and this makes it possible for the architect and engineer to work on the project at once. If I was the engineer, I would just click Receive Changes, and then I could notice that the architect has changed the position of this door. And if I wanted to now make the update to the structural model, I would first reserve all the objects in the file. And here in the 3D view, you can see that my ArchiFrame model has the wrong position for the door opening. To update the position of the door, I will first select the ArchiFrame element and then simply click Update Element Openings. So now the ArchiFrame model is consistent with the Archicad model. If the Archicad wall and the ArchiFrame boards are hidden, then you can see the new opening in the framing layer of the wall. So basically, this video just demonstrated how easy it is to notice the updates to your model and then to make the updates using ArchiFrame. So now let's move on to how ArchiFrame helps you automate some parts of the design process. In the previous video, we already got a hint of this, because in the video when the position of the door changed, we did not have to remodel any individual planks. Instead, we just selected the ArchiFrame element and clicked Update Openings. So the ArchiFrame element contains information on the structure you want to create. This includes what layers the wall has, the spacing between the studs in the framing, the size of the boards, and so on. Once you've created the element definition, you just need to place the element on top of an Archicad wall or floor and create planks. ArchiFrame will automatically create each individual plank and board according to the element's definition. So once you've created the element type or definition in ArchiFrame, you can easily apply that type to different kinds of walls with different shapes and different openings and so on. So there's no need to model each individual plank, and in this sense, the creation of the element is automated. And then if you need to update the design, this can also be done with a few clicks, just like we saw in the video. Here's a video giving a brief intro to ArchiFrame elements. There is also a longer demo at the end of the presentation, since elements are such a key ArchiFrame tool. So this video shows how you can use ArchiFrame elements to create detailed structures on top of the Archicad wall and floor shown here. Let's start with the wall. The first step is to choose the wall element type. Then you have to check wall settings such as height. And then let's place the wall element. The wall element is basically a simplified temporary version of the wall. If we repeat this process for the floor, then we have two elements that are shown here. And now we can edit the shape of the elements by, for example, making the outer layers of the wall taller. And once the shape of the elements is good, we can finish the wall by creating planks and do the same thing for the floor. So now you can see the final structures. ArchiFrame has created individual planks and boards for each layer of the wall and floor. Here's the battens layer and the boarding layer. So you can see how the ArchiFrame model is much more detailed than the Archicad model, and how easy it was to create all of these complex structures using the element process. And in addition to the rectangular elements that we just saw in the videos, ArchiFrame also offers more versatile tools for editing individual planks and creating elements with more complex shapes. ArchiFrame's plank tools include joints, cuts, and machinings. For example, in this image on the right, there is a joint between the diagonal rafter and the blue beam. The blue beam also has grooves in places where it intersects with the red rafters. And here I have a video demonstrating how easy it is to create these machinings and cuts and joints. So first, let's improve the shape of this blue rafter ending, or plank beam ending. Then let's add a drill hole to the right-hand side plank. And finally, we'll create a joint between the beam and the diagonal plank. First, select the bottom beam and then navigate to its element elevation drawing. So the end of the beam should have the same shape as the red fill. In the special plank tool, let's first select the shape of the fill and then apply that shape to the wing of the beam. In the 3D view, you can now see the result. Then let's move on to drilling the hole. This is easiest to do in the plan view. And I'll drill the hole through the top rafter using the drilling tool. So now you can see the new hole in 3D. Then let's replace the existing joint with a new one. Here's a list of machinings for the selected beam. So we want to delete the grooves at the bottom. And we also want to delete the angled end of the smaller plank. Now we can create the new joint by first selecting the beam as the operator, then using the diagonal plank to create a tenon and mortise joint. So here's the result. The joint is also visible in the beam. The list of machinings now includes the joint. If necessary, I could easily delete or edit the tenon and mortise joint later. ArchiFrame also makes it easy to create complex roofs with valley rafters, and below you can see the framing layer of a wall element with a more complex shape, rather than the basic rectangular wall we saw in the video. This video demonstrates how to add valley rafters and grooves to your planks. So first, let's add the missing valley rafter here. So to do so, I will select two perpendicular rafters and add the new valley rafter plank using the valley rafter tool. Then I'll trim the side rafters to the valley rafters. And do the same on the left. So here's the result. Finally, let's create grooves around the smaller beam supporting the rafters. I will select the bottom beam as the operator, and then create the grooves with the top rafters. So here's the result. You can keep track of the machinings in each plank with the machinings list. So using the list, I can select and delete the grooves that I just created. So now the grooves on the top surface are gone, and only some drill holes and other grooves remain. So far, we've only been looking at ArchiFrame's own features. However, it's also important to remember that Archicad and ArchiFrame form a package. In the next few slides, I'll show how ArchiFrame users can benefit from many useful Archicad features that increase the efficiency of the design process. I'll talk about Archicad's layout tools, which ArchiFrame builds upon. Also talk about Archicad's collision detection feature, which creates a warning when two objects in the model intersect. And thirdly, I'll give a brief demo on Archicad's energy evaluation tool. So here's a video on the layouts. So when you create ArchiFrame elements, ArchiFrame automatically generates an elevation drawing for each element. The drawing also contains a list of all objects in the element. It also has information like the element's ID. And these elements can easily be turned into PDFs and layouts. I'll first select the drawings I want to turn into layouts. Then in the ArchiFrame Layouts tool, I can define settings like the size of the layouts and the scale of the drawings. The layouts now appear in Archicad's layout list and can be easily edited and exported as PDFs. And this video shows how you can check whether your model contains collisions using the collision detection. We'll check whether any ArchiFrame planks collide with any pipe segments. Archicad tells us we have 9 collisions. And it also creates a list of all collisions. You can highlight the list, all the collisions in 3D. And now it's easy to fix the collisions by using the pipe to drill holes in the floor joists. This can be done with ArchiFrame's drilling tool. So I'll use the pipe as the operator and just select the joists and click Do. And the diameter of the hole is larger than the diameter of the pipe, so there are no more collisions. And the third video I'll show is the one on energy evaluation. With Archicad, you can create a detailed energy evaluation report on your project. The report includes information like the consumption and cost of energy per square meter, how the building's energy balance varies by month, how the total energy consumption is divided between energy sources, and between consumption targets like heating, cooling, and lighting. The report is useful because it lets you compare the energy performance of different versions of your design. For example, we could compare the energy consumption of this house when its windows are triple glazed compared to double glazed. Using triple glazing would save 446 kilowatt hours per year. You need three kinds of information to create the evaluation. First, basic 3D geometry information. Second, information on building systems, occupancy profile, and energy sources. And third, information on the building's environment, like the climate and the site. Once you have supplied this information, the energy report can be created with a few clicks. The report can then be edited and downloaded as a PDF. Now let's move on to ArchiFrame features that are relevant to the production phase of your project. Most importantly, ArchiFrame automatically creates element drawings based on your 3D model, as we saw in the layouts video. The element drawings also automatically contain a list of each plank in your model. The content of the drawings can be customized according to your wishes. ArchiFrame and Archicad also provide other tools to create quantity takeoffs. These tools are flexible, allowing you to choose what information is displayed. So for example, in the bottom image, there is a list of all machinings that each plank has. In the rightmost column, there is also a projection of each plank. The quantity takeoffs can be exported to Excel, where they are easy to edit or share with others. With ArchiFrame, it is also possible to export the model information directly to a CNC machine. So exporting a CNC file from Archicad is very easy. You just create a 3D model and define a few settings related to the file type, and then create the CNC file. Having the CNC file come directly from your 3D model is useful because it helps you avoid errors in the manufacturing phase. Essentially, you are able to control the entire process from initial planning and design to the actual physical cutting of timber elements in the factory. ArchiFrame's CNC export is compatible with many different kinds of CNC machines, including Hundegger, Randick, Weinmann, and H&M machines. ArchiFrame's support can also tailor the CNC output to suit your specific needs. And here is a picture of one of our clients, Weinmann CNC station. The framing and the batten layers are visible at the bottom, and currently the machine is cutting a window opening in the cladding. And here's the finished wall element. Then let's move on to how ArchiFrame supports the construction phase of your project. So ArchiFrame's overall workflow reduces the scope for error in your project. In this workflow, the 3D model, construction drawings, and factory elements are all based on the same file and therefore consistent with one another. This helps to avoid situations where on-site, your drawing and the building elements contradict one another. Another benefit of ArchiFrame and Archicad during the construction phase is that you can view your 3D models and drawings through the BIMx viewer on-site. So in essence, BIMx is an app that works online on tablets and phones. Viewing your model through BIMx provides a lot of flexibility and additional features compared to paper drawings. With BIMx, you can view and rotate 3D views. You can easily find drawings from a list, and you can access extra information by clicking on objects. And on the next slide, I have a video that explains in more detail why BIMx is useful. So with BIMx, you can view your Archicad and ArchiFrame models and drawings online or on a mobile device. BIMx is helpful in many different phases of the design and construction process. With BIMx, it's easy to share your ideas with clients who are not familiar with 3D modeling software. This is because with BIMx, clients can open the 3D model online or on a mobile device without needing an Archicad license. 3D views and drawings are shown as a list, making it easy for the client to find content. BIMx also shows the location of floor plans and sections in the 3D view, making it easy to understand how the 2D drawings relate to a 3D model. Element assemblers at the factory can also use BIMx to consult element elevation drawings. Finally, builders on site can consult 3D diagrams to check where each element or plank with a certain ID belongs. Builders can also click objects in the model to access information. For example, clicking this plank shows the length of the plank and when it will be transported on site. You could also add other information, like a link to the manufacturer's website or assembly instructions. And lastly, builders can use the BIMx model to check how difficult details should be built. So in this case, understanding this part of the building might be easier from a 3D model compared to, for example, 2D drawings. So ArchiFrame clients come from all over the world, from the Nordics to New Zealand and even Papua New Guinea. Most clients are involved in more than one phase of the building process. For example, many do both the structural design and the element production. This makes sense because, as I've told you, ArchiFrame brings a lot of benefits to the transitions between different phases. Here is one hotel project from Austria, which uses both timber framing and CLT. The circular image on the left shows the ArchiFrame model. Here's another reference from Austria. This building is an ecological center with a nature laboratory. Here's a more urban project, a wooden apartment building in Finland with elements produced by VVR Wood. The ArchiFrame reference is the yellow building on the right. VVR is a pretty important client for us. They have their own element factory in Finland that you can see here. And they have a wide range of projects from smaller homes to apartment buildings and public buildings. They therefore need a program that offers versatility and customization, and that's why they like to use ArchiFrame. Here's another project from Austria, and a few more images. And lastly, here's a reference from Jan Frode Nielsen, who works for 123, a design-build company in Norway. 123 chose ArchiFrame because of the amount of control and flexibility that ArchiFrame offers in the design phase. They also like how the end product is very predictable and looks just like in the 3D model. And they also like how user-friendly ArchiFrame is. In the building site shown in the picture, the ground floor assembly took just one day. So you can see that everything went very smoothly on the construction site. Now moving on to the price of ArchiFrame. The price is similar to the price of Archicad, and in addition, if you want to have CNC support, that will be an extra 50%. So with that, you can customize your CNC output in ArchiFrame, and we can also help you set up your CNC machine. The service contract is similar to Archicad, and yeah, basically ask your local reseller for more details. Finally, I'll just provide a quick recap of the main points in this presentation and why you should choose ArchiFrame. So first of all, think of ArchiFrame and Archicad as a package. Archicad's wide range of tools, such as layouts and collision detection, are compatible with ArchiFrame objects, and therefore, as an ArchiFrame user, you can benefit from these features. In addition, the fact that ArchiFrame is integrated with Archicad means that you mostly don't have to learn new workflows. And then moving on to the more specific features of Archicad and ArchiFrame that benefit you. So in the design phase, teamwork makes updating the project very easy, since it allows several people to edit the file at once and make sure that the file you're working on is always up to date. ArchiFrame's element tools also allow you to apply a predefined structural type to different kinds of walls and floors with just a few clicks. ArchiFrame also offers versatile tools for editing planks, including creating roofs, valley rafters, and joints. During the production phase, you can benefit from ArchiFrame's element drawings, quantity takeoffs, and CNC compatibility. And finally, in the building phase, ArchiFrame's overall workflow ensures that there are no inconsistencies between your drawings and the elements that arrive on site. Furthermore, builders can view the drawings, 3D model, and other information in the BIMx app. This can also help to reduce errors and increase efficiency. Here are some more demo videos that show in more detail how ArchiFrame works. In case you want to know about any of these features, please let me know and we can watch some of these demos. So the first video shows how you can define the element type, add elements, and create planks. This is more detailed than the previous element video we watched because it actually goes through the steps of creating the element structure, which is pretty fundamental to the process. The second demo shows how to create a roof structure from start to finish using planks. Thirdly, there's a video that looks at layout and quantity takeoffs in a bit more detail. And the fourth video shows the process of creating an energy evaluation report, including in more detail the steps that you need to follow to create that. And finally, the fifth video looks at BIMx in more detail. So are there any videos that you would be particularly interested in watching, or do you have some other questions for me?